Hello everyone, welcome back to our channel gsipucmysuru. MYSURU. This is the second session of our first chapter, that is Introduction to Electronics. In the earlier session, that is in the session 1 of this same chapter, we discussed about the definition of electronics and how these electronic devices were developed with the vacuum tube devices, the semiconductors and the transistor. In this session, we are going to see the next type of semiconductor devices which was invented, which is called as the field effect transistor. This field effect transistor is called as the FET. This FET, that is field effect transistor, was invented by the scientist Shockley in the year 1951. In 1951, Shockley proposed the junction field effect transistor, which is called as JFET, using the effect of applied field on the conductivity of the semiconductor devices. That is, the flow of current can be controlled by applying the voltage externally to the terminals of this field effect transistor. Every electronic devices will be having the terminals. So, by applying the external electric field or by varying the voltage which is applied to the terminals of this FET, we can control the flow of current. So, in the process of developing this FET, in the year 1958, the reliable FET was produced. That is, in the 1958, the useful FET was introduced or was produced. In the process of producing this reliable FET, another important device was introduced, or another important device was produced, what was named as the MOSFET. MOSFET, that is metal oxide semiconductor field effect transistors. With the improvement in processing and the device design, and also the developments in the computer industry, made these MOS devices as the most widely used transistor. These MOSFETs are nowadays used as transistors in all of the circuits. The next semiconductor device, or the next electronic device, what is called as power devices, was invented by the Bell Laboratory or the Bell Telephone Industries in the year 1956. 1956 ನಲ್ಲಿ in the Bell Telephone Industries, these power devices was manufactured. All the semiconductor devices are made up of the semiconductor materials. In a semiconductor, there are two types of semiconductor materials, that is P-type semiconductor, the other one is N-type of semiconductor. When I am going to construct a simple diode, I have to use one P-type of semiconductor, the other one N-type of semiconductor. When I am going to combine one P-type with one N-type of semiconductor, then I am going to get a diode with two terminals, and those terminals will be named as anode and cathode. In the year 1956, Bell Telephone Industry people introduced another device which was having 4 different layers. Here I am having only 2 different layers. One layer is P-type of semiconductor, the other layer is N-type of semiconductor. On a whole, this entire thing can be called as a simple diode. But PNPN, that is a 4-layer device, was produced or was invented by these Bell Telephone Industry people, and it contained 3 terminals, and that particular device was named as SCR or Transistor. What is this SCR? SCR is nothing but silicon controlled rectifier, and this SCR or the silicon controlled rectifier is also called as the thyristors, and these thyristors or the SCRs are mainly used in HVDC transmission. HVDC transmission ಅಂತ ಹೇಳಿದ್ರೆ HVDC transmission, high voltage direct current transmission, and it is also used to convert the single phase to 3 phase, or it's also used to convert AC signals to DC signal, or DC signals to AC signals, DC to DC and AC to AC. The process of converting AC to DC signals is called as the rectifiers or the rectification, and converting DC signal to AC signals is called as inverter, or the inverter circuit is used to convert the given DC signal to AC signals. And converting a DC signal to another DC signals, I mean to say some level of DC signal I be having, I want to convert, I have to increase the DC voltage or decrease the DC voltage anta hendaga we need a circuit. Then that kind of circuit is called as chopper. And converting AC to AC signal anta helidre, it is nothing but a voltage controller. In all these type of circuits, we are going to use these power devices, that is SCR, and another device is there which is called as IGBT. IGBT anta helidre insulated gate bipolar transistor. These two devices, that is SCR and IGBTs, are playing a major role in HVDC transmission, that is high voltage direct current transmission, where I need to transfer the direct current to a long distance through underwater, athwa single phase in a 3 phase ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, or converting AC to DC, DC to AC and all these things. And also in the induction cookers we are going to use these kind of devices, that is IGBT and SCRs, where I need to control the power of that particular devices. And these days power devices are available with voltage ratings of several thousands of volts and a current rating of several thousand of amps. So these power devices are playing a major role in today's science and technology. The next type of electronic devices which was invented or which was developed was integrated circuits, which is denoted by IC. These integrated circuits was invented by the scientist Jack Kilby. Jack Kilby got an idea of constructing the entire electronic circuit on a single silicon wafer. One silicon wafer na takondo aa silicon wafer mele the entire electronic circuit athwa circuit anta helidre I'll be having a different components. I'll be having transistors, diodes, resistors, capacitors, adr jotege connections from one terminal inda innond terminal ge connection madlebekagtade. So all these or the complete electronic circuit na silicon wafer mele construct ಮಾಡಬೇಕು ಅನ್ನೋ idea first ಬಂದಿದೆ for this person, that is the Jack Kilby. So the design and fabrication of this electronic components on the integrated circuit itself is called as the microelectronics. So all the active components and all the passive components and their interconnections can be done on a single silicon wafer. All the active components anta helidre the diodes irbodu, transistors irbodu. Passive components anta helidaga resistors, capacitors, inductors anta barutte. So whenever I want to construct one complete electronic circuit, I cannot construct the circuit only with the help of only the active components. I have to use some of the passive components. So I have to use the passive components, I have to use the active components, and the interconnections of all these components has to be done in one single silicon wafer or the silicon chip during the manufacturing process. By doing this, the size as well as the weight of the entire electronic circuit was reduced to a larger extent. Microprocessor and microelectronics anta ee nadve ನಾವು ತುಂಬಾನೇ ಕೇಳ್ತೀವಿ. So this microprocessor is an example for the VLSI. So what is this VLSI? VLSI, very large scale integration. Initially, these ICs contained only 2 transistors on a single silicon wafer. Adre, with the improvement in the science and technology, we can place a lot many number of components on a single silicon wafer. Eshtond number of components na ನಾವು ಒಂದೇ silicon wafer ಮೇಲೆ place ಮಾಡಿ ಅದನ್ನ ನಾವು fabricate ಮಾಡಬಹುದು. Depending upon the number of components which is included in the integrated circuit, we are going to classify this IC in terms of scale of integration. Scale of integration mele, I mean to say how many number of components are placed on a single silicon wafer. Adra mele we are going to classify these ICs as, first of all, discrete transistor, where only one transistor will be placed in an IC. That was done in the year 1951, and in the year 1960 small scale integration was produced. In the year 1966 medium scale integration. In the year 1969 large scale integration. 1975 very large scale integration. 1990 ultra large scale integration, and in the year 2001 giant scale integration was produced. I mean to say, depending upon the number of components we are going to place on a single silicon wafer, we are going to classify these ICs in this manner. In the discrete transistor, only a single transistor will be placed on a silicon wafer. In a SCI, that is small scale integration. Sorry, this is SSI. Small scale integration alli fewer than 100 components will be placed on a single silicon wafer. In the medium scale integration, 100 to 1000 number of components will be placed on a single silicon wafer. In the large scale integration, 1000 to 10,000 number of components will be placed. Very large scale integration anta bandaga 10,000 to 10 to the power of 6 number of components. Ultra large scale anta bandaga 10 to the power of 6 to 10 to the power of 7 number of components will be placed. Coming to this giant scale integration, more than 10 to the power of 7 number of components will be placed on a single silicon wafer. But these days microprocessor comes under this very large scale integration. But ivagina ICs nalli we are going to place a billion and a million number of components. Billion number of transistors and million number of gates will be placed on a single silicon wafer or on a single silicon chip. So this is all about the integrated circuits. Integrated circuits anta helidaga, again we can classify that into digital integrated circuit and analog integrated circuits. The growth of computer industry evolved new IC development, which in turn changed the architecture of a computer. Long years back, we had a computer which was used to perform only the addition and subtraction. That was as big as a single room. But today, with the improvement in the science and technology, that too with the improvement in these electronic devices and with the development of the computer industries, the computer size has decreased to a larger extent. Speed, power consumption and the component densities are the important considerations of today's digital ICs. Whenever you want to purchase a mobile phone or a simple laptop, you are going to talk about the speed as well as the power consumption. Speed anta helidaga GB RAM ide athwa hard disk capacity eno idanellanu ನಾವು discuss ಮಾಡ್ತೀವಿ, or we are going to ask all these things with the shopkeeper. So we want to know the speed, or we want to know the battery life of the mobile phone what we are purchasing. So in today's science and technology, this digital integrated circuit is playing a major role. There are a number of technologies developed in order to design or in order to construct these digital ICs. Some of them are the DTL, the diode transistor logic, TTL, transistor logic, ECL, emitter coupled logic. So these are some of the technologies what we are going to use in order to construct this digital ICs. MOSFETs find major applications in semiconductor memories. Semiconductor memories anta helidaga we are going to talk about RAM in computer, that is random access memory. How many GB is your RAM anta usually we are going to ask whenever we are going to talk about a laptop or a simple computer. We are going to talk in terms of 32 GB RAM. A mobile phone example say irbodu 32 GB RAM or 64 GB RAM anta helide. So what is the GB? GB stands for gigabyte. GB stands for gigabyte. Giga ಅಂತ ಹೇಳಿದ್ರೆ it is nothing but 10 to the power of 9. Byte ಅಂತ ಹೇಳಿದ್ರೆ 8 bits will be equal to 1 byte. Bits ಅಂತ ಹೇಳಿದ್ರೆ it can either be 0 or 1. So if I am going to write a series of numbers like this, it contains 8 bits 1 2 3 4 5 6 7 8. So totally this 8 bits is called as 1 byte. So ಈ ಥರದ್ದು we'll be having 10 to the power of 9 bytes or 10 to the power of 9 bytes places in order to save any of the data in our mobile phone. Accordingly, using this MOS technology, RAM having a capacity of 16,000 bit was first constructed in the year 1973, and 64,000 bits of memory spaces were available, and that was constructed in the year 1978. And in the year 1982, the RAM, which was having a capability to hold 2,88,000 bits of memory spaces was constructed. But in the year 1967, ROM was developed. ROM anta helidre read only memory. But initially we were not able to manipulate this ROM, or whatever the data was stored in the ROM, that is read only memory, those data was not able to be manipulated by the user. But with the improvement in the science and technology, these ROMs are available as P-ROMs or EPROMs, that is programmable read-only memory and erasable programmable read-only memory. So with the invention of these PROMs and EPROMs, we can easily modify the data, we can easily delete the data, and we can change the data whatever we want to. With the invention of this integrated circuit, that too with the invention of this digital ICs, the computer structure or the computer architecture has changed to a larger extent as it was in the earlier days, which was performing only the addition and subtraction or only the addition and multiplication. But nowadays we are having a computer which is as big as our palm, and using that particular single device or using that particular single computer, we can perform any number of jobs or any number of tasks. Now we are going to see another type of integrated circuit, what is called as analog integrated circuit. The first analog IC which was invented was op-amp in the year 1964. Op-amp stands for operational amplifier. This is the first analog integrated circuit which was invented. The other circuits or the other circuits or systems which was developed after this analog IC, that is after this op-amp, is analog to digital converter, digital to analog converter, active filters and analog multipliers. We are going to study about all these things in the second PUC electronics. Op-amp, why the name op-amp or why the name operational amplifier anta helidre, this op-amp IC is able to perform the mathematical operations like addition, subtraction, multiplication and division. Along with this, some of the derivations, integration and a logarithmic of the signals can be performed, or we can perform all these kinds of operations on the signal. Hence it is called as operational amplifier. With the invention of this analog ICs, this op-amp has replaced the discrete transistors along with the passive components which can be used as an amplifier. So amplifier anta helidre, in the first session itself I have told you, amplifier is nothing but a circuit which strengthens the weak signal. If the signal is like this, if the input signal is like this, when it is given to an amplifier circuit, the output of this signal will be the amplified version of this, that is strengthening of the weight signal itself is called as an amplifier. So with the invention of this analog IC or with the invention of this op-amp, the amplifier which was constructed with the help of a transistor, that is discrete transistor and the passive component, is completely eliminated. That is, we are going to use this op-amp as an amplifier in almost all of the electronic circuits, that can either be a simple TV or a mobile phone. So let me conclude this session at this point. In the next session, I will be coming with some more electronic devices. Until then, take care. Bye-bye.